Okay, so before moving into today's session, let's just recap what actually we learned yesterday. Then we'll directly move in our today's session. So, what exactly we actually learned today, yesterday's session is we simply learned some basic introduction things like what is data and what is the database and types of database. So I think you may remember like a types of database is a kind of RDBMS, NoSQL, and the cloud databases. So we were discussed on those things also in us yesterday. And then regarding the data warehouse. So and then difference between of database with data warehouse. And then what actually else we discussed traditional data warehouses. Traditional as cloud data warehouses differences. And then why we are using the Snowflake.
Hi,
So,
can you
ah,
maximize the screen?
okay, okay, let me increase it. Yeah, this is fine.
Yes.
Yeah, okay. So these are all the seven sample topics actually which we learned on yesterday. So don't worry, I will give you the notes. What are the definitions? I will give you everything the notes to you. So the notes and material things also we will discuss end of this session when I will share and when this uh you will be able to accessing. I will give you the idea in end of this session. Okay. So anyway, so these are all the things we learned on yesterday. Okay, today what actually we are going to learn? Today we are going to learn Snowflake architecture. So this is the most important concept in Snowflake. So basically what is architecture? So basically architecture means it's a kind of blueprint. So it's a blueprint. Blueprint means what? It's a diagram. So if you are going to build any house means what we need to do, we have to plan how this house can we are going to build. See like where this kitchen is coming, where the bathroom is coming, where the bedroom is coming. So all those diagram we are just before plan that. Before start building, we have to plan. So after planning, then only we are going to build the house. So same that plan, we are going to draw something in that paper. That paper, what we are calling as a blueprint paper. That blueprint is calling as a architecture. So we based on that architecture only, we will going to build that house, right? Same thing in Snowflake also. Snowflake architecture means how Snowflake is built and how Snowflake is processed the data, how Snowflake is handled the data, everything. What are all the layers actually it has? So if I load the data, where it will go? If I run the query, where it will go? What are all the cloud sessions we have? So like that, actually, there are so many layers we have. So we'll learn those things. So basically, in Snowflake, only we have three layers. So that's what actually very good thing. In Snowflake, just to follow three layers architecture only. So for those three layers architecture is nothing which is completely easy only. First one is a storage layer. So it's a storage layer. Second one is a compute layer, and third one is a cloud service layer. So this is what actually Snowflake following for the three different layers. Let me show you how it is looks like in Snowflake, Snowflake architecture. You see, this is how it is looks like. So it is what actually the Snowflake architecture. In here you can see we have Snowflake three layers. One is a database storage layer. Second is a query processing layer. So you see, this is a compute layer or query processing layer. So we have two names on here: query processing layer and cloud service layer. So the final one is a cloud service layer. Okay, so when whatever the new technology or whatever the tool you are going to work newly, you should understand the architecture of the respective tool. So then only you will be able to clear understanding how we are able to accessing this Snowflake. Okay, so that's what actually we are going to learn about this Snowflake architecture. This is the most important because so many interview people are also asking this question. So that's what actually I'm just going to cover on here. But this is a biggest topic. Okay, let me go one by one. So first is a storage layer. So this is what the first layer. Here you can see this is a storage layer or database storage. You can see here. So what is a storage layer? Layer is nothing where we store the data. So this is what actually we are going to store the data. So where data is stored. Data is stored. In this layer only, data is actually stored. Okay, basically, what is this layer is doing? Let me tell you clearly. Okay, so whenever we are trying to load the data, you see, if we have the data, we have the data in outside. We have some data. We are trying to load the data into our Snowflake environment. So in that Snowflake environment, where this data will going to sit? This data will going to sit under a database storage layer here itself only. Whenever we are trying to load the data, it will directly goes to on here itself only. So that's what actually Snowflake is having the separate layer for the data storage. Okay, so in this data storage layer, we have to learn three things majorly. So what are the three things? Before I get like this, like one second. Yeah, okay. Okay, so uh, I will give you the short definition of this storage layer. Then I will tell you what are all the important things we should know for this database storage layer. So basically, storage layer, when we load the data into Snowflake, when we are trying to load the data into a Snowflake, it is automatically, so we don't want to do anything. It is automatically, let me ramp it. Paratus. Okay. When we load the data in Snowflake, it is automatically stored in three things like sorry two things. One is a compressed way. So when we are trying to load the data into Snowflake, it is automatically stored in compressed and optimized. So we should know what is these two things. Optimized format. So what is this compressed and optimized format? So compressed, let me tell you. So we have one more definition also in this storage layer. I will come to that definition when it's come. So before that, I will give you the what is a compressed and optimized format, because when we trying to load the data into Snowflake, that is automatically it is done by compressed and optimized things, right? So we should understand what is this compressed. Okay. So compressed means nothing. So it is just making a data in smaller. Like you see, it's making a data smaller in size without losing the information. Without losing the information. See, if you are trying to like we have the huge files. So if you want to send those, like you can consider we have 100 files. You are going to let's consider we have 100 images. So we need to send these 100 images into using the Gmail. So what will happen? So we have to select 100 images and we need to send to them. So maybe the chances to loss we will lose the images. So maybe we'll select a 99 or 98. There is some chances. Also, we may miss some data quality images also. So what we can do instead of this thing, what we can do, like we just put all these 100 images into one folder, and then that one folder we make it as a zip format. Like a zip means we already know it is a compressed. So put it into one folder and compressing it in zip format, and then we can send that zip file into Gmail. So what will happen? So the data will never miss, because all those files I can see once this zip is extracted, and also data quality is also is perfectly we can see. So that's what actually what we are actually doing. Snowflake is automatically zipping the data. So when you are trying to load the data into a Snowflake is automatically zipping using the gun zip. I will show you that gzip. So actually, which format Snowflake is zipping means gzip. So this gzip means nothing is a gun zip. So I will show you when we are trying to load the data, automatically it is moved to gzip format. Okay, I will show you when it comes to the practical session. Okay, so first thing it is Snowflake is zipping the data because compressing. So if one more thing, like if it is 100 images, we are zipping into the we are making into zip format means like consider 100 images means like, it may 100 MB. So if after zipping, it is chances to reducing 60 MB or 70 MB like that. So actual data is 100 MB. If we are zipping, what will happen? It is reducing the size without losing information. Okay, so that's what actually I'm just mentioned in here. What actually storage layer is doing, once we load the data, automatically it is compressing without without losing any information. Okay, so that's what actually zipping is doing. And also what actually this zip is doing, let me tell you one more example. If we are going to load 10 GB of CSV file, so mostly in Snowflake we are going to load CSV file or JSON file. So let me tell you the first CSV file. CSV file means nothing, you don't worry, you just consider as a text file. For now, you just consider as a text file. I will give you the deep idea when we are moving into that. Okay, so I'm just trying to load the 10 GB of zip file. What actually Snowflake is doing, it is automatically make it a smaller version. Like it is just moved to 3 GB only. Like it is 3 GB or lesser than only. Snowflake is automatically reduce the size of actual MB to 3 GB. Why? Because actual it is a 10 GB. And zip version, this is for the compressed version. So compressed version automatically reduce the size. Okay. So that's what actually Snowflake is very useful when we are trying to load the data. It is storage cost also. We are going to pay the storage cost. For that, actually, we don't want to pay for the 10 GB of cost. We can pay only for the 3 GB because of the compression. How this compression actually it is done? So with Snowflakes follows some smart algorithms to depend the repeated patterns and store efficiently. Okay, so it is actually following for some of the pattern, and then that pattern actually used to store efficiently the data. Okay, so what is the benefit of this if you're storing like this? Because of the pay less amount, right? So if we are paying for the 10 GB, let's consider if you are purchasing for the 16 GB memory card is a comparing to 32 GB of memory card means 32 GB of memory card is a little bit higher cost, and 16 GB of memory card means bit lower cost only. So compressing 3 GB means we can store 3 GB of data only. We can pay only for those 3 GB of data. Okay, so that's what actually Snowflake is performing the compressed data. Okay, and then what is the optimized? So then we have to learn for this optimized format. It is a most important format. Actually, when we are trying to load the data, before moving into this optimized, guys, can you please confirm, are you able to catch this compressed thing in storage layer? If I'm going fast, means can you please update that? That is also
We understood.
understood, right? Okay, okay, got it. Okay, so then what is the optimized format? So optimized format means Snowflake stored the data as here. So Snowflake optimization, how it is done? Snowflake optimization is done by using the columnar format, storing data in columnar format. So you see what actually I'm trying to tell. Snowflake optimization is done by using columnar format. Then what is this columnar format? So basically this optimization is handled by columnar format. Then we should know what is this columnar format. What is columnar format? So columnar format means nothing, which is store the data in database or in table. It's a column by column. So data stored column by column, column by column. So why I'm specially telling this? Because you see, other traditional databases storing the data say row by row. So traditional database storing the data in a data stored row by row. So that's what my mic is again. Let's So Snowflake follows the columnar format for performing the optimization. Columnar format means nothing which is store the data inside in Snowflake. It's a column by column. Traditional database store the data as a row by row. So what is this row by row storing and column by column storing? Let's see how it is looks like. So we can consider as a Oracle is one of the traditional database, right? So we can considering this database. You see, if we are storing the data into an Oracle, so we have two columns, ID column and the name column. If I have like this is a file. Let's consider we have this file. We have this data file. So the data file only we are calling as a CSV file. So CSV file means nothing which is contains all the data. Okay. So now I have the file 1 and 2 and 3 and something like this, and then we have A and B and C and C. Okay. So now I have these are all the data in data file. Okay. So if I'm trying to load this file into an Oracle, how it will be load? Oracle it is load by row. You see, I'm just going to put it into a column name only. First, what we'll do? Oracle first load. So entire data actually it will be loaded in here. So entire data, whatever the data it is there, all the data it will be loaded here. And internally how data is stored in Oracle, it is row by row. So this is a first row. So what actually it is doing? Row one is 1A, and row 2 is 1B, 2B, and row 3 is 3C. So like this internally data stored in Oracle. Then how Snowflake internally stored? So same, we have the same data set. I have the same data set. So this is a CSV file. I'm just trying to load the same file into a Snowflake. So it is loading in here. Internally, what actually Snowflake is doing? So internally, Snowflake organizing column by column. So first, actually, it is taking the ID column because of this ID column first, and then put it into like this. So 1, 2, 3, and then name column. Name column is A, comma B, comma C. So this is what actually internally performing Snowflake and Oracle. So Snowflake is internally store the data is a row by row, and Oracle is store the data is a row by row, and Snowflake is store the data as a column by column. Okay, what is the purpose? Why Snowflake is store the data as a columnar format? So this is what actually the columnar format, column by column. What is the benefit? Let's say we are just trying to query something. So query means I am not explaining for till now to you. So basically, I'm just trying to tell what I just want to see the name column. So I'm just trying to write some of one of the query. If you're not understanding, please ignore. I will tell you what is a query and how we need to write in future. Just for now, I'm just writing like this. So you see, I'm just writing one statement. In this statement means what actually it is doing. I'm just asking to see the data, asking to see the name column data. So name column data. So what actually it is doing if I am asking select name from table in Oracle. So if I'm trying to write this query in Oracle, what will happen? Oracle will read entire table. So even though if we are indexing in the sense like one of the concept in Oracle, so that is actually just making organizing the way. So even though what will happen, so the table we have this table, so Oracle will never goes to directly scan alone for this column, name column. It is scan for n ID column and then name column. Then only it will be understand. Okay, so we have this name column in here. Then the user is asking for the name column. Then this will displaying only for the name column. So let's say one of the example. So if you are reading the newspaper, if you are reading the newspaper, you want to read only for the sports related news. So what we need to do, we need to first newspaper we have to open, and we need to move the pages and check one by one subtitles, like sorry, subtopics, all the places we need to find, and then only we identify the last page they are added for the sports page. So for reading for the sports news, we have to scanning entire newspaper where actually sports news are available. So then only we know. So this place actually sports news are there. So then we can start reading that. So like that Oracle also, when we are trying to asking any one of the column, but Oracle will perform in ID. Sorry, will scan ID and name. So it is not going to scan only for the name column. It is scan ID column and name column. Then only it is giving to us printing the name result. Okay. So what actually if I write the same query into the Snowflake? So I did not do anything. I'm just trying to load the data into this Snowflake. Snowflake internally performing these things. If I'm trying to write this code, so what actually internally what actually Snowflake will do? Snowflake will never going to read this ID column. Okay. So because of this ID column, it will never going to read. It is directly coming. You see, here we have one of the asterisk something you can just consider. So what will happen? Snowflake, instead of scanning entire table, okay, entire table, it is directly scanning the topic. So the topic of column name. So it is kind of stored under a metadata. So metadata means I will tell you in future. So all the column names only it is scanning. So just coming into this place, ID column and name column. Okay, here we have the name column. So it doesn't go in depth on here. But in Oracle, what actually we need, if name column means it is scanning entire table, then only this name column going to print. But in Snowflake, it just read only for the column name, then directly printing the this is print. Okay, so that's what actually Snowflake is doing. Actually that is the reason behind the thing. Snowflake is stored the data as a columnar format. So basically I will tell you one of the example in the same sports news you are going to read. Instead of newspaper, if we are reading for the this news or magazine, something magazine, so in that magazine books means instead of in-depth reading everything, we have the index page. So in that index page itself, it shows like a this is a page number. You have the in sports news. You can directly go there. So then what's happening? Actually, instead of reading for the entire pages, we directly go to the read the sports news to if we are reading the sports news in newspaper means we just wasting our times, so time waste. But in magazine book means we know the index page number, we know directly we can read there. So we are not going to waste our time. Okay, so that's what actually the difference between of row by row storage and column by column storage. Yes, Iram, something you were asking.
Yeah, Najib, Mukesh here.
Yes, okay,
I
sir.
think I got understanding in traditional method,
Mhm.
uh, if we write a query, the complete all the columns and rows will get it will read and then it will print the output, right? But in Snowflake, only it will read the columns. It will not go and read the rows and all, right?
Exactly. Yeah, it will never goes to read the
For
rows. It is
example, in Snowflake, if you have 10 column names, it will read only all 10 column names and it will print it out, right?
correct. Exactly, sir. Yeah.
Thank you. Yeah.
Yeah. Thank you. So this is what actually the difference between of the columnar storage and traditional format storage. So Snowflake is following for the columnar storage for optimized format. So because optimizing, we don't want to wasting our time, right? So that's what actually Snowflake is doing. Anyway, in Snowflake, data storage layer has two things. One is compressed and optimized format. Already we know the compressed. Compressed means reducing the memory space, and the optimized means reducing the scanning time. So these two things automatically done in storage layer. We no need to worry about anything. Okay, so this is the first thing. When we are trying to load the data, it automatically done these two things. What is the second point? I already told you there is a 2 points. So second point is, let me put it into in here. All this into one, give one tab. Okay. So second point is how actually data stored. So let me that definition as well. Okay. So actual storage, like a we're just going to the actual storage happen, how actual storage happens in Snowflake architecture. In here you see, if you are store the data in Snowflake, everyone thinking data is stored under the Snowflake storage layer. Like for now also we just learn like that only, but actual truth is data actually in Snowflake does not have its own physical memory. So that's what actually I'm trying to tell in this second point. So the second point is the actual storage happens in any one of the cloud platform, in any one of the cloud platform. So might be it can be AWS, it can be AWS S3 or Azure Blob or GCP. So Snowflake store the data using any of the cloud provider. It does not have its own memory storage. Okay, so that's what actually we are trying to tell here. So Snowflake does not have its own storage. Okay, it does not have its own storage. Instead of it is used to store the data any of the cloud provider. Now you see, if I'm giving the data into Snowflake itself, it is not storing the data. It is store the our data into any of the cloud provider. Now the some of the doubts may come. So do we need to pay for Snowflake, and then do we need to pay both Snowflake and other cloud as well? So other cloud. So because I already paid to Snowflake to store the data, okay, but Snowflake's storing our data into other clouds. Then do I need to pay for this other clouds as well into the Snowflake? But actually, absolute answer is no. We no need to pay for the other clouds. So or AWS or Azure or GCP, we no need to pay. Snowflake itself, it's handling. We just pay the amount for storage in Snowflake itself only. Snowflake will taking care of these storage things that will be taking the storage in other clouds. Why actually it is doing? See, we consider we let's take an example. We have the Netflix. So everyone is watching some movies in Netflix. You see, if Netflix is one of the OTT application, in that Netflix itself has own storage, so it has a own storage. Netflix does not have its own storage. So Netflix is a platform which is published in the movies we can just watch, but it does not have its own storage. Then how all the movies are stored behind this Netflix? So Netflix is used to AWS storage only. So Netflix purchased AWS storage. They just store all the movies into the AWS storage. Then we can directly watch. Is I am going to pay for the AWS storage as well, or only Netflix? I am directly pay only for the Netflix. Behind the scene, the Netflix handling these things. Like that same thing, if I'm paying to the Snowflake will handling the data storage. So that's what actually it doesn't have own physical storage. In Snowflake does not have its own physical storage. Instead of actually it is storing for the other clouds. So that's what the first thing. So might be some of the people get one another doubt. So the other doubt is my data is secure or not? Is it secured? Because I given my data to Snowflake only. But Snowflake, which is going to give my data to other clouds, then is this secured or not? Yes, it is absolutely secure because Snowflake has more feature to protecting our data. Like it is just doing for the encryption, and we have some access control, and then we have so many additional features we have in Snowflake. Those features actually taken care of the securities. So we don't worry about our data. It is we are just storing the data in Snowflake, but it is going to put it into other clouds means if my data maybe chances to hacking means no worries, because of Snowflake is taking care of the all the security things. We don't worry about that. There are so many features we have. So we may get one another doubt as well. So then why we need to Snowflake? Why Snowflake? Because Snowflake itself is storing the data in AWS only, right? So why Snowflake? uh, Snowflake also using the data storage from the AWS, then I can directly use the AWS, right? So instead of moving into the Snowflake. So that's what actually I already explained this thing on yesterday. So if you are want to directly store the data in the S3 means we don't know how we can do the data in securities. But in Snowflake, automatically it is done by all the security things. And also other things, yesterday we learned. So if we are storing the data in S3 means if you are not using that data, even though you have to pay for that storage consuming which you made. So, but in Snowflake, if you're not using the data, if you are not accessing the data, you don't want to pay anything. So just maintain the data inside there. Whenever you are using, that time only you can pay. So like this is kind of, I already told, like a renting policy. So AWS means it's just kind of a renting policy. You have to take 1 month of rent or 2 month of rent. So whenever you store the data, if you are not even that use the data means that is also you have to pay a whole month of data. But in Snowflake is not like that. So that's what actually why Snowflake. So we have so many features. Like first thing is security. So our data is secured by Snowflake because Snowflake is handled automatically. If I'm storing the data in AWS means we have to manage all the access control things, but we don't know. But in Snowflake can do all the things. And then second thing, so cost comparatively AWS to Snowflake. Snowflake is less cost if you are using. So that is also one of the another feature. And also one another feature means we have so many features, advanced features in available in Snowflake. Like we have time travel, and we have auto scaling, data sharing, columnar optimization, micro partition. There are so many features we have in our Snowflake. So that's what actually we just use for Snowflake for this data warehousing concept. Instead of directly we store the data into AWS. Okay. So almost I have covered these topics for the how the data is stored in Snowflake data storage layer. So guys, can you please confirm, are you able to understand how the data is stored in the storage layer? So just to give some recap for this, data is stored in data storage layer automatically. It made by compressed and optimized way, and as well as it does not have its own storage. It just store the data using the other clouds because of it is just because of the storage cost and everything. It's managed by internally. So why actually they separated, I will tell you for the in future, because we have query processing layer and query processing layer. Next layer we are going to learn for the query processing layer only. Query processing layer and storage layer, they separated. Why they are actually separated, this I will tell you in future. No worries. So for now, can you please confirm? Are you able to understand this storage layer, how it is performing?
Yes, no.
Yes, Nizam, understood.
Yeah, Ramesh, are you there? Ramesh? Okay. Okay, Jansi ma'am and Mukesh sir, so you people also got clear, right?
Yes, sir.
Okay, got it. Okay, so we just completed for the first layer for now, database storage layer. Now we will move to the query processing layer. So this is the most important layer in Snowflake. Like we can considering based on this layer only, end to end all the Snowflake is performing. Which means like all the Snowflake is running. We can consider is a engine of the layer. So if without engine, bikes or vehicle, nothing will work. So like that, this query processing layer is a most important layer. So query processing layer is using for the virtual warehouse. I will tell you one by one. Let's go slowly. So query processing layer, or the name, another name is compute layer. Maybe the chances to interviewer will ask, explain about the compute layer, means we don't get confused, because of query processing layer and compute layer, both are the same thing only. Okay, so basically here only we are processing the query. So this layer only we are processing the query. Okay, so what is the query? So because still now we are not start writing any of the single query till now. Okay, we will when we start the SQL session, that time only we are going to start writing the query. For now, what is a query? So query means nothing which is a question. So another name of query is a question. So I am just questioning to the database, something like you can consider database as a one of the information. So database having one of the information, I just ask to database, hey database, can you please show me the student names? Like that, I'm just asking to the question to database, and then database understanding, and then it will be give the answer to us. So if I'm directly ask the question to someone, means that person can understand and they will be give the answer. But in Snowflake or some database world, they does not understanding the English concept of questions. So we should tell their own understanding language. So that's what actually we use for the SQL to understand the database language. Okay, so we just give the SQL query to the database, and then database processing that SQL query, and then give the result to us. Okay, so SQL is one of the a worldwide using the query language. So whatever the database you are going to accessing, you if you know the SQL language, you may accessing all the most of the databases like we have in market Teradata, Oracle, Snowflake, MySQL. There are so many databases. If you know the SQL, you can directly handle to them. But there are some bit syntax is changed, so we can that is also not that much of a problem. Anyway, so to handling these SQL things in this query processing layer only. So whatever, so we have some data in this database layer. So we are just writing some query. That query will come to this query processing layer, and that will goes to asking the question to the database storage layer and give the information to us. Okay, so this is what actually happened. So now we want to understand how this SQL processed in this query processing layer. So if I'm give the SQL query, how this will be processing? So SQL query processing using the virtual warehouse. So how it is processing the queries. So to processing the queries using the virtual warehouse. So Snowflake uses virtual warehouse to process the SQL queries. So for SQL queries, we need a virtual warehouse. Now we may get some confusion. What is this virtual warehouse? Already we learned some warehouse. Again, there is some virtual warehouse. What is these things? I will tell you simple understanding. So you see in computer, let's take an example of computer. Every computer has two drives. So one is a C drive, another another one is a D drive. So what is the purpose of this C drive? So C drive purpose is nothing, which is actually we when we are trying to installing any software in our system, that is directly goes to the C drive to handling to RAM, everything is handling by the C drive. If you are installing the OS, that is also handling for the C drive. So whatever the installing the softwares or installing the OS, those kind of things actually taken care by this C drive only. So like it's we can consider it as a system application. So whatever the process we need to do, like a system application process we need to do, we just use for the C drive. Then what is the purpose of D drive? This D drive is stored to data. So C drive is basically C drive is for running the running the system applications. So basically used for C drive is running the system application. D drive is for storing the data. So storing the data. But people are asking, so are we are not able to store the data in C drive? We can store the data in C drive also. But as per the suggestion, whatever the your data, your own data, like images or video, something if you have, you can directly store those data in another partition of D drive. Do not store your own data, your personal data into in your C drive, because if you change the OS or if you are lost the data means the C drive will be empty, and we have to put new OS means C drive will be chances to be empty. And also, you don't store your own data in C drive because it will be how much memory space if you have free in C drive. Based on that memory space only, system working fastly or smoothly. Okay, so that's what almost all the people are maintaining for the D drive to store actual data, and then C drive left out only for running the system applications. So if it has free space, then system will run smoothly. Anyway, why I'm trying to tell this? This C drive is a virtual warehouse. We have two warehouses. One is a virtual warehouse, and one is a virtual warehouse, and D drive is a data warehouse. So, data warehouse, we already learned yesterday. What is the data warehouse? Which is nothing, which is for the store the data inside the database. It's a kind of database, collection of databases are inside the data warehouse. Then what is a virtual warehouse? Virtual warehouse is processing the query. So how system processing the system applications? Same thing. If you want to processing the query, we need a virtual warehouse in Snowflake. So I'm just telling about the Snowflake only. So if you want to processing the query, we need a virtual warehouse. Okay. So let me tell one more example. If you have a bike, so you have a bike. Okay, considering you have a bike. So you want to travel one place to another place. So if you are just traveling to one place to another place, you what actually you need? You need a fuel. So without fuel, we can't travel from one place to another place. Same thing. So if you are traveling, same thing, if we are running the query means we need a virtual warehouse. So in Snowflake, virtual warehouse is a fuel actually. Considering as it's a fuel. So if you want to go long, like a far place, so very long place means what you need? You need a more petrol. You need a more petrol. Like that same in Snowflake also, if you are running a big query, so very larger query means you need a large virtual warehouse. So I will tell you what are the warehouse actually we have. So like that actually we need. So if you want to go very shortest place means you no need to put more petrol. Just to put some basic 100 rupees or 200 rupees petrol is enough. So that is a very low cost. But if we are going to very far place means what actually we need to do? We need to put some more petrol that actually require some more cost as well. Like that, if you are running the larger query means we need use for the larger virtual warehouse, we have to pay accordingly. So it's a small virtual warehouse means that is a very less cost. If it is a large warehouse means we have to pay some more additional cost. Okay. So like that actually virtual warehouses are smaller version also we have, larger version also we have. So like that there are so many versions we have in virtual warehouse. Let me show you what are the virtual warehouses. So sizes. So it is a size, and this is we can consider as a power. So in Snowflake, virtual warehouse size actually they are referred from t-shirt size. You can consider we have size X small. So if small kid wants to wear the t-shirt means it is enough for the X small, right? So like that Snowflake also we have X small virtual warehouse that is for least power. If you are run simple select statement or simple query means it is fine for X small. So this is very less cost only. So it least power only. Okay. So and the next sizes we have small size, and then we have medium size. So these are all the Snowflake virtual warehouse sizes. In virtual warehouse sizes, it is mentioned like this: XS, it is S, it is M, which means medium, and then another size is large size L, another size is XL, X large, XL, and then we have another size is 2x and 3x and 4x large. So like this, actually, we have many sizes in virtual values. So accordingly, we need to choose which virtual values is choose for our script. We can just choose the any virtual values and we can just start writing the code. Okay. So, what is actually the payment? So, payment, I will tell you when the query comes. That time only I will show how much time actually it is running, and how much, which virtual warehouse we are using, and what is the credits we may used in here. Okay. So, basically, what actually I'm trying to tell, the query processing layer, if you want to processing the query, we need a virtual warehouse. If you are processing the biggest query, you need any size of bigger virtual warehouses on here. Okay. Okay. So almost we understand for this query processing layer, but we need to learn some more important points in this query processing layer, because most of the interviewer will asking this scaling policy. This scaling policy in comes under this query processing layer only. So that's what actually this is a subtopic, scaling in Snowflake. So what is a scaling in Snowflake? I already told you, just remember whenever you hear the word of this scaling, you just remember it is a kind of a rubber band. So why I'm just telling? Because if you want, you can expand. You can expand whatever the size you can expand. If you don't want, you can shrink. Shrink means just decrease the size. So scaling means expand, which means rubber band. If you want, you can expand, and if you don't want, you can reduce the size. Okay, so just remember this. Then I will tell you what are the scaling policies we have in Snowflake. Then you will get understanding. Okay, so Snowflake actually follows two variety of scaling policy. So first one is scale up. First one is a scale up and scale down. Scale up and scale down. And second one is scale out and scale in. Scale out and scale in. So this is the two variety Snowflake actually it is following. So, okay, what is the scaling? What is the purpose of using on here? What are the things actually basically used in here? Okay, let me tell you first what is a scale up. What is a scale up? Scale up means we are just increasing the size of one warehouse to another warehouse. So, something like you just consider if you are running one of the query, so that query will take more than 5 minutes or more than 10 minutes. Then immediately you can just stop that query. So while running that query, if taking more than usual time, usually most of the query will run for 3 to 4 minutes in Snowflake side. If it is taking more than 5 minutes or more than 10 minutes means immediately stop this running the query, then confirm with your leads. So this do we have any other virtual warehouses like we in our real-time project, they will give you for the they will not give you all this size of virtual warehouses because they want to pay some amount for this based on the virtual warehouses. In my real-time project, they for me actually they given for these two virtual warehouses. If my query is running very slow means I just change it to medium virtual warehouse, then that query will be executing within 3 minutes. So if we are in the one of the virtual warehouse, we can change the virtual warehouse while running the code itself only. So if we are running the code, if you are running the query, it taking time. So time taken means we just do stop the code, stop the query and change the virtual warehouse, change the virtual warehouse, then run again, then run again. Okay, so then run again. So this is what actually the scale up. Whenever we need, we can increase the virtual warehouse size. Whenever we no need, we can just decrease the virtual warehouse size. So we don't want to always be stay on this larger warehouse. We can just go with smaller warehouse as well. So the based on the query itself only it is decided. So that's what actually it is rubber band. So if you want, you can increase, or if you don't want, you can just decrease. So that's what actually scale up. Scale up means increasing the, so increasing the size of warehouse, increasing the size of warehouse. Then already if scale up means increasing the size of warehouse means, then scale down means decreasing the size of warehouse. Scale down means nothing, which is decreasing the size of warehouse based on the query. Based on the query. Okay, so when actually this scale up and scale down will do, we already know when the query is running, that time only we need to increase or decrease. So without running, what will happen for this virtual warehouse? So for this virtual warehouse, while running the query, on that time only we record this. Without running the query, we know it. Like you consider when you are driving, on that time only fuel will be start using. Without driving, that fuel will never waste. So that always stays in the snow bike only. Like that, virtual warehouse when we are created, so if I'm creating the virtual warehouse, so once after creating the virtual warehouse, the payment will start like that. If you're asking, no, payment will never start in virtual warehouse when after creating. When we using the virtual warehouse, that time only we need to pay. So without using the virtual warehouse, we don't want to pay. So that's what actually Snowflake is following for the pay as you go method. Pay as you go method. When you use that time, that time only you can pay. If you are not use, you don't want to pay any single amount for the virtual warehouse for running the code. Okay. So that's what actually scale up and scale down, increasing or decreasing the virtual warehouse size based on the query. Then what is a scale out in scaling? So scale out means, which is actually, let me tell you, scale out means adding the multiple virtual warehouses. You see, adding the multiple virtual warehouse. So let's consider you have one of the petrol tank in your bike. Petrol tank in your bike. So if you are traveling smaller, like a nearby places, means that is one tank of bike is petrol is enough. We can just travel to you using that petrol. But if you're traveling very longest place, like so if you're going to Ladakh, means somewhere you don't see any petrol bunks, so you can't put the petrol if suddenly it is stopped. Then what you can do? You are maintaining one more tank, like you take care of one another tank of petrol purchasing, and when it is petrol is finished in your bike, then again you pouring it this petrol. So that's what actually the scale out means. So we were using one of the virtual warehouse. So some users using the virtual warehouse, which means some of the users are running the query using this virtual warehouse, means other users if trying to running the same virtual warehouse, means this will busy because already some of the people are using, so we can't run others users as well to here. So do one thing, you can in Snowflake will suggesting us, do one thing, you can just add one more virtual warehouse. So that is actually done by automatically in Snowflake. We don't want to additionally add it manually, because you see, so user one is running one code and user two also running one code. User one is using virtual warehouse one, and the user two also trying to running the same, trying to using the same virtual warehouse one, means the user two will maybe move to queue, which means once after he's finishing this running the code, then only this user two can run. So that's what actually Snowflake, what actually it is doing. Instead of waiting for here, Snowflake will have another visual warehouses as well. So it is just redirecting to them and then adding the, like it is kind of adding the multiple virtual warehouses. That's what actually the scale out. Instead of asking to us, it will be automatically done by itself only. So that's what actually the scale out. So then already scaling. If scale out means, then scaling is also same only. Like reduce the multiple virtual warehouse. So if it is recurred means, it will be automatically adding one more virtual warehouse. If it is not required means it will be automatically reduced. If if suppose it is already introduce another virtual warehouse means it don't use another virtual warehouse if it is not running the another queries. So in here, scale out or scaling, it is not adding another virtual warehouses, it is adding the another clusters. So I will tell you what is a cluster for now in future. The next I'm going to tell that one only. For now, you just understanding if it is running more users, we need more virtual warehouse. If running less users, we no need more virtual warehouses. So that is taken care by Snowflake. So in here, this is what actually auto scaling is done. Auto scaling is done in here. Auto scaling in the sense, in the meaning of auto scaling is Snowflake is automatically understanding of when it's required for adding more virtual warehouses. When it doesn't require, it can just reduce the virtual warehouses. So automatically it is done. So we no need to worry about that thing. So that is what actually the that is what actually the scale up, scale down, scale out, scaling. In interviewer, they will never ask you directly what is scale up or scaling, what is scale down or scale out. Like that, they are not asking. We have another name of this. So what is the scale up or scale down means nothing, which is a vertical. It is a vertical scaling. So interview will ask you what is the vertical scaling, and then what is a in here the name is horizontal scaling. So they will ask you explain the horizontal scaling, and they will ask you explaining the vertical scaling. So vertical scaling in the sense nothing, which is what actually we are increasing the size of virtual warehouses. So small to medium, medium to large, like that we are just increasing the size. Like let me put it into here itself only. Increasing the size of virtual warehouse, and then horizontal increasing or decreasing. So let's consider increasing or decreasing the size of virtual warehouse. And then horizontal scaling means nothing, which is adding or reducing the clusters, reducing the clusters. So it is not actually virtual warehouse. For now, I'm just, for example, I'm just told you, it is just increasing or reducing the virtual warehouse. So now horizontal scaling is adding or reducing the clusters. Then what is a cluster? So this is a most important thing. So let me tell you the clusters meaning. So clusters mean it is a system. So you don't worry. This is completely simple only. A computer. A cluster mean a single cluster mean a computer. A computer, or we can consider as a server. Server. Okay. For example, let me tell you what is a cluster. Some day shift person, one of the person working in day shift in company. Let's consider one of the companies, a X company, is working in day shift. His shift timing is ending, start from 11 to 8 p.m. So this is what actually his shift time. So day shift person using for the system number, system number, system A. Okay. So then same company, night shift person also will come. His shift time start from 8 p.m. to morning 5 a.m. So like that we can consider. So he is also going to use the same system. So what I'm trying to tell here, so you see, we have the only one system. That one system name is called system A. System A. So this is one of the only one system we have. So day shift person is working on this shift, this system. So night shift person also need to working on the same system. So when he logged out at 8 o'clock, then only night shift guy can come and start working in his work, right? So maybe if day shift person is extended his work means, so maybe if he is not logged out at 8 o'clock, instead of he is logged out at 9 o'clock means he has wait, night shift person wait 1 hour. So until he move, then only he can start work on here. So he has to wait. So that's what actually the problem. So what actually a manager will do, manager or lead will do, instead of waiting you can use another system until he is logged out. So we have another system name is a B system. So the person, day shift person working on here, once after lockdown, you can just go here. Otherwise, you just do night shift person can start working on this system. So if both are working different system means the production will never get problem. So everyone can do the proper production. If even though the night shift person can extend it, day shift person can extend it, night shift person also can start working in a different separate system. Same thing in the cluster. Same thing in Snowflake is also following. So user user A is used to running the query. So he is running the query, to using the any one of the virtual warehouse, using the any one of the virtual warehouse. So and same like a user B also will start running the query. He is also asking to I need to use for the same virtual warehouse. So what will happen? This user B query will not running. This will goes to queue mode. In Snowflake world, they are telling is a queue mode. Instead of running, it will be moved to queue mode until the A person complete its query, then only the B person can run. So that's what actually the problem. So how many person we can stay until the queue mode? So that's what actually we are doing. While creating the virtual warehouse, we have to enable one button. So there is a one button which is what actually calling as a multi-cluster. So multi-cluster, if we are enable this button and we have to do some setup, I will tell you what are all the setups, how to enable, how to create the virtual warehouse, everything while coming into the query part. I will show you each step by step. Don't worry. So for now, I'm just trying to tell we are creating the virtual warehouse. On that 10 itself, we have to enable the multi-cluster. If you are enabling the multi-cluster, what will happen? Instead of waiting this guy to for this virtual warehouse, in this virtual warehouse itself has multiple system. If we are enabling the multi-cluster, we have multi-port. You can considering as a multi-port. So like this it will be. So A person will use this port, B person can use this port, and C person also can use this port. Like that actually will happen. So that's what actually when we are creating the virtual warehouse, we need to enable for the multi-cluster. Okay, so multi-cluster means nothing which is multiple computers which is used to running the multiple queries simultaneously without waiting or queue. Okay, so that's what actually what is this query processing layer. In this query processing layer, we should learn this much is enough for now because almost we completed the 1 hour, and also this is almost a Snowflake's day one. So if we give so much stuff means you will get maybe confusion. So for now, I'm just to give summarizing whatever we learned today, and then we'll end up this session. So what actually we learned today? So we just start learning for the Snowflake architecture. So for Snowflake architecture, we have three different layers actually it is maintaining. One is a storage, another one is a compute, another one is a cloud service layer. Storage layer means we are storing the data inside the storage layer only. The storage layer have two things. One is a compressed and optimized format. Compressed means we already know it's a compressing the data, and optimized means it is just following for the columnar format to reducing the scanning time. And then it is does not store the directly in Snowflake. It is store the data in other cloud storage layers. So why it is happening, all those things already we learned. And then what is a compute layer also we completed. Compute layer means nothing which is a query processing layer. Here itself only we are just processing the query. If you want to run more queries, we need a more virtual warehouses. Like we just learned let me come to here. So what are all the things actually we learn for this query processing layer? It's like sizes of virtual warehouses and scaling the virtual warehouse and the multi-cluster of virtual warehouse. All those things actually we learn. So the scaling and the multi-cluster, all those are most important things. Interview definitely will ask. Explain about query processing and the clusters and multi-clusters and scaling policies means we have to tell those things. Okay. So guys, I will going to end up this session. So guys, if you have any question, you can ask, or else if I'm just closing this recording, you can ask that time also. Let me close this recording. Today's session is over.